the whole of trigonometry. It will be, of course, very fast. You can catch up and you can go through very slowly, and you can go through again and again and make a proper note, because all will be helping you from time to time. Okay, can you see the screen? One of you please respond. Hello.
Yes, sir. Now I can see, sir.
Okay. Now we are sitting our trigonometry, what you studied in 11th. Can you recollect how we started your trigonometry? We started with a, if you remember, we started with a unit circle. What is a unit circle? A unit circle is a circle with the center at origin and having radius 1 unit. Okay. Well, what is its equation? Equation to unit circle is x squared plus y squared equal to 1. That means any point on this circle satisfies this equation, and any ordered pair xy or any point xy satisfying this equation will lie on the unit circle. Okay. So for example, 1 0 will satisfy the equation and it lies on the unit circle. In fact, 1 0 is the point where the unit circle intersect the positive x-axis. 1 by 2 root 3 by 2 lies on unit circle, and so on. Some points I have listed here. Let the unit circle intersect the positive x-axis at A10. No doubt we have seen that point. A10, the unit circle intersect the positive x-axis at A10, no doubt. Now suppose that theta is any real number. Maybe positive, maybe negative, maybe 0 also, any real number. And let Pxy be the point on the unit circle, so that the angle POA, what is P? P is the given point on the unit circle, O is the center of the circle, A is A10. And suppose angle POA is theta, which is measured in anti-clockwise if theta is more than 0, and measured in clockwise if theta is less than 0. So here I have taken up theta positive, and it is measured in anti-clockwise direction. P is the point here. Angle POA is theta, and P has the coordinate xy. X coordinate is x, y coordinate is y. Here we define cos theta as x and sin theta as y. See how cos theta is defined and sin theta is defined. Cos theta is the x coordinate of that point P, where angle POA is theta. Where is A? A is the point where the unit circle intersect the positive x-axis. And what is sin theta? Sin theta is the y coordinate. So if we want cos theta and sin theta, we need the x coordinate and y coordinate of that point P, where angle POA is theta. Right? This is as good as the definition which we have seen in traditionally in for a right angle triangle. Sin theta is opposite side by hypotenuse. Opposite side is PM. Hypotenuse is OP. Of course, this is only when theta is between 0 and pi by 2. But what we defined is for any real value of theta. So opposite side is y. Adjacent side, hypotenuse is 1. So that is y by 1, that is y. And cos theta is adjacent side by hypotenuse, that is OM by OP. OP is 1, OM is x. So cos theta is x. So the definition will very much match with the definition taken up with the right angle triangle. Now if theta is pi by 2, how to find cos theta and sin theta? First of all, we must find the point P, where angle POA is pi by 2. Which will be the point on the unit circle, so that angle POA is pi by 2. P will be the point B. Let me call it the point B, where point B is at 0, 1, which intersects the y-axis. This angle BOA, it will be pi by 2. And what is the x coordinate? 0, and y coordinate 1. That means cos pi by 2 is the x coordinate, that is 0, and sin pi by 2 is the y coordinate, that is 1. Look up, if it is pi, what happens? If it is pi, which point will be there? So that angle POA is pi, it will be the point, let me call it C. it will be actually a straight angle. Angle COA is pi. And C has the coordinates -1 and 0. So x coordinate is cos theta, y coordinate is sin theta. So cos pi is -1 and sin pi, the y coordinate 0. Very simple to find cos value and sin value, provided you can trace that point P where angle POA is not changing, angle POA is theta. Well, the other trigonometric functions, tan theta is sin theta by cos theta, and cot theta is cos theta by sin theta. Further, sec theta is 1 by cos theta, and cosec theta is 1 by sin theta. All these are defined when the denominator is not equal to 0. Be careful. Well, we have defined tan theta as opposite by adjacent side, and all these we know. Tan theta, cot theta, sec theta, and cosec theta. That also matches with this definition. Now the identities, we start with the fundamental identity. This is the fundamental identity of trigonometry, that is cos squared theta plus sin squared theta is equal to 1. And from there we can derive, if you divide the equation, this identity through both the sides with the cos squared theta, you get 1 plus tan squared theta is sec squared theta, and that is as good as sec squared theta minus 1 equal to tan squared theta. And if you divide with sin squared theta, you get 1 plus cot squared theta is cosec squared theta, or cosec squared theta minus 1 is cot squared theta. These things you studied earlier. Now the signs of trigonometric function in quadrants. We divide the whole plane into 4 congruent quadrants with the help of 2 mutually perpendicular lines. I give the names for the quadrants 1, 2, 3, 4 in anti-clockwise direction. First quadrant where both x and y positive. Second quadrant where x negative, y positive. Third quadrant where both x and y negative. Fourth quadrant where x positive, y negative. That means x is cos theta and y is sin theta. So in first quadrant both are positive, means cos theta and sin theta are positive. Their ratios and reciprocal are all positive in first quadrant. Second quadrant, y coordinate is positive, that is sin theta and reciprocal positive. Third quadrant both negative, that means sin theta and cos theta negative, but then the ratio is positive. And fourth quadrant, x coordinate is positive, that is cos theta and the reciprocal positive, all the rest negative. So you know it, only for you to remember it. In first quadrant all positive, second quadrant sin and reciprocal positive, all the rest negative. Third quadrant tan and cot positive, all the rest negative. Fourth quadrant cos and sec positive, all the rest negative. Okay, you may remember A, S, T, C. A all positive, S sin positive, T tan positive, C cos positive. Of course, sin positive and it is reciprocal cosec, tan positive and it is reciprocal cot, cos positive and it is reciprocal sec positive. Well, now formula for minus theta, you can easily bring out sin minus theta is minus sin theta, cos minus theta is cos theta. Further, when you take the ratio and reciprocal, you usually get tan minus theta is minus tan theta, cot minus theta is minus cot theta, sec minus theta is sec theta, and cosec minus theta is minus cosec theta. So this shows that the cos function and sec function are even functions, whereas sin, tan, cot, and cosec are odd functions. What is an even function? A real function f is called an even function if f of minus x equal to fx for all x in the domain. You can see cos is an even function, sec is an even function. If you want more even functions, you can have fx equal to x raised to 4 is an even function. Fx equal to x squared is an even function. Whereas odd function, if f of minus x is minus fx, it's an odd function. Here which are odd functions? Sin, tan, cot, and cosec are odd functions. You can have fx equal to x cube is an odd function. We will have more about even function and odd functions. Further formula for complementary angles, pi by 2 minus theta. Sin pi by 2 minus theta is cos theta. Cos pi by 2 minus theta is sin theta. We are not going for the proofs. I am only refining the results. Tan goes to cot. Cot goes to tan. See, this is a relation. Sin and cosine, they are complementary. Why? Because for complementary angles, they have same values. Tan and cot are complementaries. Sec and cosec. Cosec and sec, they are complementary functions to each other. Now, if you go for pi by 2 plus theta, remember the signs changed in some of that. Sin and cosec remains positive itself, whereas the rest, cos pi by 2 plus theta is minus sin theta. Tan pi by 2 plus theta is minus cot theta. Cot pi by 2 plus theta is minus tan theta. Nothing to worry about remembering this. I will tell you an easy way to remember. Now, further, when you go for pi minus theta, one thing, sine and cosec are positive again, the rest are negative, but sine is the same function. Sine, all functions goes to the same function. But which is positive, which is negative, we'll come to that once again. When you go to pi plus theta, only tan and cot are positive. You know, tan and cot are positive because it is in quadrant 3, pi plus theta, and all the rest are negative. So what you remember now is, first of all, if theta is a positive quantity in first quadrant, pi by 2 minus theta is also in first quadrant. First thing, pi by 2 minus theta is also in first quadrant. Whereas pi by 2 plus theta is in second quadrant, pi minus theta again in first quadrant. Okay? Pi minus theta is in first quadrant. Pi plus theta is in quadrant 2. 3 pi by 2 is here. 3 pi by 2 minus theta is in quadrant. 3 pi plus theta and 3 pi by 2 minus theta is in quadrant 3. 3 pi by 2 plus theta go to quadrant 4. 2 pi minus theta also is in quadrant 4. So first of all, the given number, you identify in which quadrant it falls. Further, once you identify the quadrants, remember that if you have integer multiple of pi plus or minus theta, remember, integer multiple of pi plus or minus theta, we have the same function of theta. If it is sine, you get sine. If it is cos, you get cos. If it is tan, you get tan, and all. The only thing is that whether it is a positive quantity or a negative quantity, it all depends on the quadrant and this principle ASTC, the sign convention. If it is in first quadrant, all positive. Second quadrant, sine and reciprocal positive. Third quadrant, tan and cot positive. Fourth quadrant, cos and reciprocal positive. So if it is integer multiple plus or minus theta, same function. So for example, if you have sine pi plus theta, first of all, it is same function, sine theta, and pi plus theta goes to quadrant 3, so it is sine is negative, so minus sine theta. Whereas if it is an odd multiple of pi by 2, that is 2k plus 1 pi by 2 plus or minus theta, it goes to complementary function of theta. Sine plus or minus depends on the quadrant, whether 2k plus 1 pi by 2 plus or minus theta goes to which quadrant it is. It all depends on that. So for example, if you want sine 3 pi by 2 plus theta, sine 3 pi by 2 plus theta, it goes to complementary function cos, no problem. 3 pi by 2 plus theta is in quadrant 4. The sine function will be negative there. It will be minus cos theta. Well, let us take some example. Sine pi plus theta. Pi plus theta goes to quadrant 3, sine is negative. Cos 3 pi by 2 minus theta. 3 pi by 2 minus theta is again quadrant 3. Cos will be negative there, and it goes to complementary function minus sine theta. Tan pi plus theta quadrant 3, tan is positive, and same function, so tan theta. Cos 3 pi by 2 plus theta, remember cos 3 pi by 2 plus theta, which quadrant it is? 3 pi by 2 plus theta is in quadrant 4, it goes to complementary function, cos goes to sine. Now third quadrant 4, cos is positive, it will be plus sine theta. Not that sine theta is positive there. This cos theta will be a positive quantity in the fourth quadrant. And what is that quantity? Quantity is sine theta. 3 pi by 2 plus minus will go to complementary function. Whether it is integer multiple of pi plus or minus theta goes to same function. And even if you have bigger one, 23 pi by 4, 23, nearest multiple of 4 is 24. It is 24 pi minus pi by 4, or that is 6 pi minus pi by 4. 6 pi, look at, start with the 0, then pi, 2 pi. 2 pi, 4 pi, 6 pi will come towards positive x-axis. Minus theta, minus pi by 4 goes to quadrant 4. In quadrant 4, sine function is negative, and 6 pi minus will be same function. So that is minus sine theta, minus sine pi by 4, that is minus 1 by root 2. Well, more problems you have to take up. Formula for alpha plus beta and alpha minus beta. Cos alpha plus beta, you know it is cos alpha cos beta minus, you may have to remember it, cos alpha cos beta minus sin alpha sin beta, whereas cos alpha minus beta is cos alpha cos beta plus sin alpha sin beta, whereas sin alpha plus beta is sin alpha cos beta plus cos alpha sin beta, sin alpha minus beta is sin alpha cos beta minus cos alpha sin beta. Tan alpha plus beta is tan alpha plus tan beta upon 1 minus tan alpha tan beta. Tan alpha minus beta is tan alpha minus tan beta upon 1 plus tan alpha tan beta. I have not written code, which is we can manage with time. Factor formula and converse. Sin c plus sin d is 2 sin c plus d by 2 into cos c minus d by 2. Whereas sin c minus sin d is 2 cos c plus d by 2 into sin c minus d by 2. Cos c plus cos d, both are cos here, 2 cos c plus d by 2 into cos c minus d by 2, whereas cos c minus cos d is minus 2 sin c plus d by 2 into sin c minus d by 2. The converse, 2 sin a cos b is sin a plus b plus sin a minus b, 2 cos a sin b is sin a plus b minus sin a minus b, 2 cos a cos b, cos a plus b plus cos a minus b, and 2 sin a sin b, cos a minus b minus cos a plus b. Formula for 2a, multiply this. Sin 2a, 2 sin a cos a, no doubt. Cos 2a, we have 3 formula, cos squared a minus sin squared a, 1 minus 2 sin squared a, and 2 cos squared a minus 1. Okay, all these are highly important. Tan 2a, it is 2 tan a by 1 minus tan squared a. This can be applied for half angle also. The same I can write as sin a equal to 2 sin a by 2 cos a by 2, and cos a will be cos squared a by 2 minus sin squared a by 2, or 1 minus 2 sin squared a by 2, or 2 cos squared a by 2 minus 1, and tan a will be 2 tan a by 2 upon 1 minus tan squared a by 2. Formula for 3a, sin 3a is 3 sin a minus 4 sin cube a, cos 3a is 4 cos cube a minus 3 cos a, tan 3a is 3 tan a minus tan cube a upon 1 minus 3 tan squared a. And from here, very importantly, from here we can find sin cube a. Sin cube a is 1 by 4 into 3 sin a minus sin 3a, and from here you can get cos cube a will be 1 by 4 into 3 cos a plus cos 3a. Very important, we may need it later. Very important formula here, sin 2a, cos 2a, and tan 2a in terms of tan a. Sin 2a is 2 tan a by 1 plus tan squared a, cos 2a is 1 minus tan squared a by 1 plus tan squared a, and tan 2a we have already seen 2 tan a by 1 minus tan squared a. Remember, sin 2a and tan 2a, the difference is here in the denominator. This sin squared a, cos squared a, and tan squared a you can write in terms of cos 2a, one of the most important formula. 2 sin squared a is 1 minus cos 2a, that actually we are deriving from cos 2a. 2 sin squared a is 1 minus cos 2a, or sin squared a is 1 minus cos 2a by 2, or you may remember like this, 1 minus cos 2a is 2 sin squared a, or sin squared a is 1 minus cos 2a by 2. Remember, we needed to apply it many places. 1 plus cos 2a is 2 cos squared a, or 2 cos squared a is 1 plus cos 2a, or cos squared a is 1 plus cos 2a by 2. Very important. And tan squared a will be sin squared a by cos squared a, that is 1 minus cos 2a upon 1 plus cos 2a. This can be applied even for half angle, that is sin squared a by 2 is 1 minus cos a by 2. Here instead of a I have a by 2. More importantly, you can remember 1 minus cos a is 2 sine squared A by 2. Similarly, 1 plus cos A is 2 cos squared A by 2. And 1 minus cos A by 1 plus cos A is tan squared A by 2. Well, we have completed almost all the formula which we needed. Now we go for some special values. You remember it, you know it. What we more importantly need is we need all these in radians. 0 degree, that is 0 radians, 30 degrees, pi by 6, 45 degrees, pi by 4, 60 degrees, pi by 3, 90 degrees, pi by 2, and further we know. Sine value and cos value. If we know sine value and cos value, the ratio of them is tan value, and the remaining reciprocal of sine is cosec, reciprocal of cos is sec, and reciprocal of tan is cot. I hope you know it. I don't need to read all these values, you know it. This is tan pi by 2, we know is not defined. Okay, tan pi by 2 is not defined. When tan theta is 0, cot theta is not defined. When sine theta is 0, cosec theta is not defined. And when cos theta is 0, sec theta is not defined. Let us see how we take up some more examples here. Very simple. Tan pi by 4 plus x. It is tan a plus b, tan a plus tan b upon 1 minus tan a tan b. When you apply that, tan pi by 4 plus tan x upon 1 minus tan pi by 4 tan x. Tan pi by 4 is 1. And hence, remember, you may keep this as formula. You may tremendously require this kind of formula many places. Tan pi by 4 plus x is 1 plus tan x by 1 minus tan x. And tan pi by 4 minus x is 1 minus tan x by 1 plus tan x. You may have to retain. What is 1 plus tan x by 1 minus tan x? That is tan pi by 4 plus x. And what is 1 minus tan x by 1 plus tan x? That is tan pi by 4 minus x. Suppose I ask to prove cos x minus sin x by cos x plus sin x is tan pi by 4 minus x. What I take is that take left side, divide numerator and denominator with cos x, you get 1 minus tan x by 1 plus tan x, that is tan pi by 4 minus x. Okay? Look at this. Prove that 1 minus cos x by sin x is tan x by 2 and 1 minus sin x by cos x is tan pi by 4 minus x by 2. See, 1 minus cos x, do you remember 1 minus cos x is 2 sin squared x by 2 and sin x is 2 sin x by 2 cos x by 2. When 2 goes, 1 sin x by 2 goes, you get sin x by 2 by cos x by 2, that is tan x by 2. Whereas the second one, 1 minus sin x by cos x, how will you apply that? What we know is that 1 minus cos x is 2 sin squared x by 2. So what you apply is that sin x you write as cos pi by 2 minus x and cos x denominator you write as sin pi by 2 minus x. And 1 minus cos theta is 2 sin squared theta by 2. So 1 minus cos pi by 2 minus x is 2 sin squared theta by 2, that is pi by 4 minus x by 2. And sin theta is 2 sin theta by 2 cos theta by 2. 2 goes, 1 sin goes, this is sin by cos tan pi by 4 minus x by 2. If you want, you can write in terms of cot also. Cot of pi by 2 minus this, that will be cot pi by 4 plus x by 2. Anyway, I'm just sharing some questions here. I've gone very fast, I'm sure, but all these were known to you. What I'm only reminding that this formula, you need it. So I hope I can complete your trigonometry by now. I hope you are clear with this. You may have to go through it again and again. Okay? Are you happy? Many are not here. I will send the recordings to you on the way. You may please go through it, make a complete